Hello everyone. Welcome to SHR Trinity. Today, we conclude our zero-shot prompting interview series with part 5. Let's get started. Before we begin, if you're looking for practical, industry-oriented training in artificial intelligence and generative AI, SHR Trinity offers a comprehensive 30-hour training program. For complete course details, check the description below. Now let's begin today's interview session. We will now begin with questions 41 to 50 of our zero-shot prompting interview series. Moving on to question 41, how do you build a zero-shot intent classifier for a massive enterprise system?
In a massive enterprise architecture, a zero-shot intent classifier serves as the foundational router that directs user queries to specialized downstream agents. Because it must handle unbounded, unpredictable user input at high speeds, you cannot rely on slow few-shot prompts. The architectural key is hierarchical categorization. Instead of asking the model to pick from 50 different micro-intents in one zero-shot prompt, you structure it as a cascade. The first zero-shot prompt categorizes the query into one of three macrodomains, like sales, support, or engineering. Once routed to support, a secondary, highly targeted zero-shot prompt classifies it into specific support buckets like password reset or server outage. This cascaded zero-shot approach drastically reduces token overhead, lowers latency, and ensures high accuracy by narrowing the semantic search space at each step.
Moving on to question 42, how does zero-shot prompting change when shifting from GPT 3.5 to GPT-4 class models?
The shift from smaller models to frontier models like GPT-4 fundamentally changes prompt engineering. With older or smaller models, zero-shot often required extreme hand-holding. You had to meticulously structure sentences, define obvious constraints, and avoid any complex logic because the models lacked deep reasoning capabilities. With GPT-4 class models, the zero-shot capability is emergent and robust. You can provide highly complex, multivariable instructions in a single zero-shot prompt, such as extract all legal entities, evaluate their risk, and format them as a nested JSON schema. A frontier model can execute this perfectly without examples. The engineering shift moves away from how do I trick the model into formatting this correctly toward how do I provide the most comprehensive, precise system rules to govern its advanced reasoning.
Moving on to question 43, what is zero-shot semantic parsing and when is it useful?
Zero-shot semantic parsing is the technique of instructing an LLM to take unstructured natural language and map it directly into a structured API payload or query language. For example, converting book a flight to NYC next Tuesday under $500 into a rigid JSON payload matching your flight booking API. This is incredibly useful for building natural language interfaces for traditional software. In your zero-shot prompt, you provide the system with the exact JSON schema and the data types required by your API, and you instruct the model to map the user's intent to those keys. Because modern LLMs are trained heavily on code and JSON structures, they can perform this semantic mapping accurately without needing multiple examples of user utterances mapped to JSON.
Moving on to question 44, how do you enforce deterministic behavior in zero-shot pipelines?
LLMs are inherently non-deterministic, probabilistic engines, which makes enforcing strict determinism in zero-shot pipelines an engineering challenge. You must address this on two fronts, model configuration and prompt architecture. At the configuration level, you must set the API temperature parameter to 0, which forces the model to select the most probable token at every step, minimizing creative variance. At the prompt architecture level, you enforce determinism by eliminating all subjective language and using binary or constrained output structures. For instance, instead of asking "analyze this user's mood," you ask, "map the user's text to exactly one of the following enumerations: happy, angry, confused." By locking the temperature and heavily restricting the output space, you can achieve near-deterministic behavior in production.
Moving on to question 45, what are zero-shot hallucination vectors, and how do you monitor them?
In zero-shot prompting, hallucination vectors refer to the specific probabilistic paths where a model is most likely to invent information due to a lack of anchoring examples. The most common vector is the empty set problem. When you ask a model to extract information that doesn't exist in the text, its default behavior is often to hallucinate a plausible answer to fulfill the instruction. To monitor and mitigate this, you must build explicit escape hatches into your prompts. You must instruct the model, if the requested data is not present in the text, output exactly the phrase, no_data_found. In production, you monitor the frequency of the no_data_found outputs versus hallucinations caught by downstream validation logic to continuously refine the strictness of your zero-shot constraints.
Moving on to question 46. How do you handle contextual dependencies in zero-shot document analysis?
When applying zero-shot prompting to long document analysis, a major challenge is contextual dependencies, where information at the end of a document changes the meaning of information at the beginning. Because LLMs process text sequentially through self-attention, they can sometimes lose the thread of complex dependencies in massive texts. To handle this in a zero-shot environment, you should instruct the model to perform a two-pass analysis within its output. You prompt the model to first output a brief summary of the core entities and their relationships, and then, based on that summary, answer the specific question. By forcing the model to explicitly write out the context first, you inject that context directly into its short-term generation window, significantly improving the accuracy of the final answer.
Moving on to question 47. How do you scale zero-shot prompts across thousands of varying user inputs?
Scaling zero-shot prompts requires moving away from static prompt strings toward dynamic prompt templates. In an enterprise system processing thousands of varied inputs, hard-coding a prompt is brittle. Instead, you build a templating engine using a library like Jinja or LangChain. Your zero-shot prompt becomes a dynamic blueprint where constraints and schemas are injected programmatically based on the user's session context. For example, if a user is in the finance module, the application dynamically injects finance-specific negative constraints into the zero-shot system prompt before sending it to the API. This dynamic generation of zero-shot instructions allows a single core architecture to scale securely across highly diverse user interactions.
Moving on to question 48. What is the role of XML tags in isolating variables within a zero-shot prompt?
In zero-shot prompting, you are often feeding untrusted or messy user data directly into the LLM alongside your strict system instructions. If the user data contains commands like ignore previous instructions, it can cause prompt injection. XML tags are a critical structural tool to isolate variables and protect the prompt's integrity. By wrapping the user data in tags, such as user_input data/user_input, and explicitly telling the model only analyze the text inside the user_input tags, you create a strong semantic boundary. The LLM's attention mechanism learns to treat the content inside the tag strictly as data to be processed, rather than instructions to be executed, making your zero-shot pipeline vastly more secure and reliable.
Moving on to question 49. How do you orchestrate multiple zero-shot agents to solve a single complex task?
Orchestrating multiple zero-shot agents is the foundation of advanced AI workflows, often referred to as agentic architectures. Instead of relying on one massive, complex prompt, you deploy a fleet of narrow, highly specialized zero-shot agents. For example, to generate a research report, Agent A is given a zero-shot prompt to purely extract facts from a database. Its output is passed to Agent B, whose zero-shot prompt strictly evaluates the facts for bias. Finally, Agent C takes the validated facts and uses a zero-shot prompt to format them into a markdown report. Because each agent operates with a hyper-narrow, pure zero-shot instruction, they execute with extreme speed and low token cost. The orchestration layer simply manages the data handoffs between these lightning-fast microagents.
Moving on to our final question, to conclude our zero-shot series, how will this technique evolve over the next 3 years?
Over the next 3 years, zero-shot prompting will evolve from a manual engineering discipline into a native, programmatic API standard. As foundation models become exponentially better at reasoning and alignment, the need for few-shot examples will approach zero for 99% of business tasks. We will see the rise of schema-driven generation, where developers no longer write natural language instructions at all. Instead, you will simply pass a strict JSON schema or a Python pydantic model directly to the API, and the LLM's zero-shot capabilities will instantly map the unstructured input into your precise architecture. Mastering zero-shot constrained engineering today prepares you for this future, where AI development is less about chatting with models and entirely about designing strict data contracts and robust orchestration pipelines.
Excellent. You've completed the final part of our zero-shot prompting interview series. If you found this video helpful, please like, share, subscribe to SHR Trinity, and press the notification bell so you never miss our upcoming AI interview preparation videos. Thank you for watching. See you in the next series.